All right, good morning, calculus. So we are going to take a little run through some sections this morning. I'll put them up one at a time. This is going to be a little redundant because this is kind of what we talked about in the class meeting last week, but but here we go. All right, so let's see what we have here. We have sharing the screen. Okay, are we sharing the screen? No. Here we go. Share the screen. So, hold on, let me pause this for a second because I need to put up a little sheet here. Okay, there we go. So I just need a little something to kind of work through some things here. So here we go. So, yeah, evaluate the following integral. So here's the big mistake that people make when we do this. All right. So we have integral x squared times quantity x squared plus 9 dx. All right, so let's go ahead and write this down. So we have, okay, right. So we have, let's go ahead. We have integral 8x squared, I believe, and then we had an x squared plus 9, yeah? X squared plus 9. Okay, biggest mistake people make is that they want to do something like this. They want to integrate the 8x cubed, or 8x squared rather, times integral x squared plus 9. Don't do it this way. Okay, you'll be sad, I'll be sad, everybody will be sad. This is not a good way to go. So you want to avoid this. You don't want to break integrals across with the times in the middle of them. There's another rule for that. We're going to learn that in chapter 8. But for now, you can't do this, okay? And even when you do it, you can't really, you got to do a special thing. Kind of like when we have product rule. Like if we took the derivative of this, I'd have to take derivative of the first times the second plus the first times the derivative of the second. It's the same kind of thing for integrals, okay? So you can't just break them apart with the times button here. It doesn't work. So what we're going to have to do in this case is we're going to have to say, well, this is integral of 8x to the fourth, right? When the bases are the same, we add the exponents together, plus, and then we have 8 times 9, which is going to be 72, and there's no x's, that's just going to be x squared, and we integrate that way. Okay, so just be real careful that you're doing this properly and you're doing it correctly. Now we can integrate, and that's going to be 8. This is going to be x to the 5th over 5, and this is going to be plus 72 times x cubed over 3. Don't forget, constant, right? It's automatic grade reduction if you forget your constant. Okay, so remember to do that. So here we have 8/5, right? X to the 5th plus, now I got to do 72 divided by 3, and I think that is 24. So we have 24x cubed plus c, and that is going to be what we're doing here, okay? So just in conclusion, just to remember, you can separate the integrals out with a plus. Like if you wanted to integrate 8x to the 4th dx plus 72x squared dx, you're certainly allowed to do that. If there's a plus or a minus between them, you can separate them out. If there's a times, you may not do this, okay? So that's pretty much how we do something like that, all right? So let's go ahead and take a look. 3, 5, we'll just make this a little bit longer. All right, I think, pardon me, like I said, this might be a little bit redundant from the class meeting. So, I'm sorry for that, but that's what we have. Okay, so we have pi, this is x cubed, plus e squared over the square root of x. Okay, now the biggest mistake students will make here is you need to change this to put these up on the top. Okay, put this one up on the top. We need to change it to a negative exponent. Okay, we can break them apart, treat them as two integrals if we want to. Okay, but we need to move them up onto the baseline. So we have integral of pi x to the minus 3 plus e squared times x to the negative 1/2. Okay, if you leave them down on the bottom and apply power rule, it's not going to work. Okay. So when we go ahead and integrate these two, what we're going to do is we're going to add one of the exponents. So pi, and then if you're $3 in debt and you pay one back, you are now $2 in debt. Congratulations. We're there. Okay. You might think the e squared, like we have to do some kind of an exponent thing. E squared, that's a regular number, right? This is just a constant. So we just have e squared. We're just dealing with the variable. Now this is way different than e to the x, right? Times square root of x. That would be completely different. Okay, but here we just have the we just have the e to the x part, and then we're ready to go. Okay, so this is going to be x. You're $half in debt, u plus 1, right? So that's going to be a positive 1/2 divided by a positive 1/2, and again plus c. So we're going to have an pi over 2 negative x to the negative 2 plus, how do we get rid of this, right? This is like a 2 over 1 times 2 over 1. So this is going to cancel, and we have 2e squared constant, remember? X to the positive 1/2 plus c. Okay, and that's what we're looking for. If you wanted to make this a little bit different, make it look a little different, you certainly could. We'll write the positive one first. We could say this is 2e squared times the square root of x minus pi over, and this is going to go down on the bottom now. So we have a 2x squared down here plus our c. So that would also be a way to say this. This might be a little prettier, but they're going to be effectively the same thing. Okay. So again, just remember that you have to put them, if you have fractions, you have to make them negative exponents first before you can do anything. Okay, so power rule does not apply to like a 1 over x or anything on the bottom here. So be careful about that. That's the mistake that people make. All right. Next we have here, I think that was number 7, right? What was this? This was 5. Okay. So let's have a look at question 7. Okay. This one's not so bad. I kind of wish your book would put these specifically in the next section, because I never memorized the formula for it, and I would not expect you to do that either. So we have integral of 2e to the negative 0.4. Okay, just make sure the decimal's in the right spot. X dx. Okay. Now there is a formula to do this, and I know you have to memorize this in Calc 1. Again, I never did. When I learned this, it was way after U substitution. So I'm just used to saying, well, let u equal negative 0.4x du, okay, is negative 0.4 dx. All right. So we could do something like this, where we could say dx is equal to du over 0.4, okay, with a negative sign there. Okay, and go ahead and substitute, and that's fine. Okay, there's many different ways to go through and deal with your du. Use the one that works for you. Okay, you don't have to do it my way. The book shows you this way almost all the time. It's a fine method. Okay, I was just taught a different way of doing this, but you know, many roads lead to Rome, right? So if it works, it works. And so we have integral of 2. We have e to the negative 0.4x, but we call that u. Okay, and instead of a dx, remember you have to have a u and a du. We can't have, if you still have a dx in your integrand, this part, you haven't finished it yet. You have to make sure you're going to get this all done. Okay, so this is du over 0.4. There's a negative here. It's all times. All right. So let's clean this up a little bit. So this is 2 over 0.4. I'll put the negative out here. So all I did was I slid all of my constants through the integral sign. You're allowed to do that. Okay. And we have integral of e to the u du. Okay, now if it's attached to a plus, you can't slide them out. Okay, if there's a plus in here, right? You have to slide out constant terms. You can't slide out like, well, this had an 8 and this had a 7. You can't do that. Okay. So what we're going to do now is we're going to say, well, what is right? This is 2 divided by 4/10, right? Because that's what 0.4 is. So this is 2 times 10 over 4. This will cancel a little bit. So we've got 2 here. So this is 5. So this is going to be -5. What's the integral of e to the u du? It's the easiest integral anybody will ask you, right? There you go. So it's -5. E to the u is -0.04 or -0.4. Sorry, said that wrong. Okay, so we have -0.4x, right? Because we're back to here, plus c, and there you go. All right. So that's kind of how I learned it. I didn't learn like just doing it this way, but if you memorize this, you're like, damn it, I memorized this. I paid for this. I'm gonna use it. Go right ahead. All right, I did not. Never paid for that. Okay, so I like to use U substitution on those. Okay, that was question 7. How about question 9? Oh, this is a good one. Question 10. I did this one in the okay, we'll do that one next. All right, I think we did this one in the class meeting as well. So for this one, it's kind of a mess. All right, we have integral of square root of x plus 6, that's both on the top, divided by 5 cube root of x dx. All right. So the issue here is, again, you can't do this. You can't do, well, this is integral root 6 plus, or root x plus 6 divided by integral of 5 cube root of x. You cannot do this, okay? So if you decide like, oh, I know, I'll break it up into 2 integrals, like not like this, you won't, okay? Again, you'll we'll all be very unhappy, okay? So this is not going to lead you to a good grade. So what we have to do is we do have to deal with this thing here, but we have to do it in a special way. So the problem is that first off, we can break apart the top. So if I have an a plus b over a c, we could say this is ac plus bc. We're allowed to do that, but we can't break apart the top, or the bottom rather. Okay, if you have an a over a b plus c, this is not the same as a over b plus a over c, right? That fractions don't work that way. Okay, the top we can, but the bottom, that ain't gonna go, okay? So the idea is like, look, if you have 4 quarters, you have $1, right? And I could have 1 quarter in one pocket, 3 quarters in a different pocket, and we're gonna be okay. But if I have 4 quarters and I wrote it as 3 plus 1, right, we had 4 quarters. That's not quite enough to do laundry, but I cannot break it apart to do this, right? That's $4 plus $1.33. Like, if you walked into the laundromat, you're not walking out $4 and another $1.33 here. Okay, so you can't do it that way. So what we have to do is we have to break apart the top here. So this is going to be square root of x over 5 cube root of x plus 6 over 5 cube root of x. I don't know how that does this. I don't know how to turn that off either. I'm sorry. That's what we have. All right. So we have to deal with the exponents here. So this is, right, this is x to the 1/2 over 5x to the 1/3. Okay. Plus, and then we have 6/5, right? 6 over 5 times 1 over x to the 1/3. All right. So the way we're going to do that is we have a rule, right? When you're dividing by things with exponents, we take the top exponent minus the bottom exponent, provided the bases are the same. So this is 1/5 right? Times, what's a half minus a third? Well, half minus a third is a sixth. Okay, plus, and then we have 6/5. This is still all integrated here. And then we're just going to bring this one up because we like to integrate with things in the baseline rather than things on the top and the bottom. Sometimes we like that too, but we have the x here. Okay, and I'm just going to break it up into two different integrals because we have a plus between them. So we're allowed to say, well, this is 1/5 x to the 1/6 plus integral 6/5 x to the negative 1/3 and dx for both of them. Okay, so that's how we're going to deal with this. So I have to add 1 to this. Okay, so this is plus 6/6. So we have 1/5 x to the 1/6 plus 6/6. That's 7/6, but divided by 7/6. Just whatever you write up here goes down here as well. Plus 6/5. We're going to add 3/3. So -1 plus 3, that is x to the 2/3 divided by 2/3. Okay, so plus c. Okay, so now we're going to go ahead and deal with the fractions that are on the bottom. So that's a 6/7. That's a 6/7. Okay, so this is going to be, this will cancel. So 6/7 times 1/5. Okay, I'm sure that's delightful, but that's going to be 6/35. There's nothing that'll cancel there. And we have x to the 7/6 here, plus, and then here we have 3/2, 3/2. So the 2's will kind of cancel. We could leave that to later if we wanted to. So we have 6 times 3 is 18, divided by 5 times 2 is 10. Okay, 5 times this 2. We have x to the 2/3 plus 3. We can go ahead and reduce a little bit. So this is 6/35, x to the 7/6 plus, this like can cast out a 2. That's going to be 9/5, x to the 2/3 plus c. And that is going to be our solution for this one. Okay, so the trick here, or the trick, but the way to untie this knot is we deal with this fraction. Okay, instead of dealing with like two pieces the way you might think about it, we're going to deal with two pieces like first term and second term. Okay, so just be real careful about that. That's a very common mistake that a lot of calc students make. So I just want to warn you about that. Make sure that you're separating them out on the bottom this way. Okay, so if this had extra terms in it, we'd have extra terms. Okay, so sometimes you don't have to do that. You know, the U substitution section will find some really nice ones, but you know, if you do have to deal with it, that's how you take it apart. Okay. So let's see here. Let's go ahead and do the next one. Okay. So this is how you deal with the C. Okay. So we have a function satisfying that f prime of x, so the derivative is equal to, what do we have here? We have 9x to the negative 14/15. 9x to the negative 14/15, right? And they tell us that f of -1, didn't want this to happen, f of -1 is -8. Okay, and then we're just going to go ahead and deal with that. So we need to figure out f first, or at least we have to get an idea of what f is first. So we have a derivative here. We're just going to integrate the derivative. So this is 9x to the negative 14/15. And what we're going to do is we're just going to add 1. We're just going to add 15/15. It's 1. So negative 14 plus 15 is equal to, right, 1/15. Okay, so we have 1/15. And then we have to divide by 1/15, don't we? Because that's the other part of this, plus c. So we're going to get rid of the 1/15 by go ahead and multiplying by inverse. So that's all going to cancel. So we have 9 times 15. What is that? 90 and 45. So that's going to be 135 x to the 1 over 15 plus c. Okay, so that's our integral. But we also know that f of 1 happens to be, what did they tell us it was? -8. So what we're going to do is we're going to type in, we're going to say this is 135 times -1, right? Oh, is it -1 or is it +1? -1, okay. So we'll be okay there. So the 15th root, right, of -1 is still -1, right? -1 times itself 15 times is -1. So, and this is equal to -8, yeah? Oh no, plus c here. Okay. So we're going to have -135. I evaluated this. Okay, -1 is going to be out in front here. Plus c is equal to -8. Right? And all we're going to do is we're just going to add the 135 to both sides, 135 to both sides. And we end up with c is equal to, what is this going to tell me? This is going to be like 127. Okay. And that is our actual function. Okay, so f of x is equal to, we have 135 x to the 1/15 plus 127. Okay, and that's going to be our function. All right. So there we go with that. Make sure I put in my -8 in here, make sure my SIGN signs are correct, and after that, we'll just go. Okay. All right, so let's see, what else are we going to do here? That was, I believe that was 8, wasn't it? Let's look at 9. Nope, that was 10, I guess. Let's look at the hard one. Okay, we have a model. Okay, this is sneaky, but it's not really so bad when you read through it. So we have a model for describing the population of adult flower beetles. It involves evaluating the following integral, where g of x is the per unit abundance growth rate of a population of size x. Okay, researchers consider this to be a simple case where g of x is equal to a minus bx for constant positives a and b. Go ahead and find the integral here. Okay. By the way, this may be a lot of what you end up doing. Okay. So we have integral of gx over x dx. And again, the same thing we did like 2 problems ago. You do not want to do something like this. Okay, this is not the way you want to go. Okay, you don't want to go and do it this way either. Okay, so these will both make us both, okay, we'll both be very unhappy. Don't do this. All right. So that's the trap they're trying to set for you. Okay, they want you to do it this way so they can mark you wrong. Don't fall for it. Okay. So what we're going to do is we're going to say, okay, well, look, this was an a plus bx, a and b are positive. Okay, divided by x. Okay, so again, right, we have a over x plus bx over x, right? That was what we're really going to integrate, right? So we could also do this with the U substitution. Okay, we could set, well, no, we can't. We don't want to do that. You don't want to do it that way. It's going to be a mess. Okay, and then we just have to integrate these 2 pieces together. But before we do that, right, we have x over x here. So we have a over x plus b integral dx. All right, so this a over x piece, that's going to be our a times ln x And then integrating b is just going to be bx. Okay, and we have our c. So this is a times ln x plus bx plus c, and that's the interval. That's how you want to go. All right. So let's see. We have a ln x. Oh, these are all positive. There's a population, right? It's unlikely we're going to have a negative populations of flower beetles here. Okay. We have a ln x. Why do we have negative? Why wouldn't it be positive? Did I mess something up here? Oh, because it's minus. So my original thought here is put a minus in here. So we'll put a minus in here. So this will be a minus, and this will be a minus. Okay. So we can see, I mean, they're gonna, it's not like a Facebook multiple choice quiz where they're gonna give you like answers are like, Cincinnati when they have this. Okay. They're gonna all be something that's like, well, that kind of seems right. And then here we go. Okay. So that's what we're going to pick. Okay, so that's C, and that's what we're trying to deal with here. Okay, so overall, it's not too bad of a section. They just kind of remind us, like, how do we do integrals again? And we're going to go from there. Okay, so good luck on finishing this homework. So we'll go from there. Okay, all right. So thank you, and I will see you in the next video.